Okay, we're going to take a look at the practice on our one sample means. So go ahead, share the screen, take a look. So we've got a situation here where it says about YouTube. YouTube here says we have an approximately normal distribution with a mean of 18.5 minutes and a standard deviation of 5.3. So that is a normal distribution, 18.5, 5.3. So the first one says A. A means 1. So again, this is back to where we started with this normal distribution. So what we're going to do is we're going to draw ourselves our normal curve. We're going to go ahead and put our center at 18.5. We're going to add 3 standard deviations. So we're going to add that 5.3. So that's going to give us 23.8, 29.1, 34.4. If I subtract those 5.3s, I get 13.2. I get 7.9. And I get 2.6. And this thing is saying the probability that a teen watches greater than 25. So again, if I'm thinking about that, I'm looking for 25. 25 is here. I go ahead and I shade in that region. There's a few ways to do it. The way that, a lot of people do it is using that normal CDF in the calculator. Normal CDF. We want to have a lower bound, we want to have an upper bound, we want to have a mean, and we want to have a standard deviation. So in this case, our lower bound is at 25. Our upper bound is lots of 9s. Our mean is, as stated, 18.5. Our standard deviation is 5.3. And then what we do is we go to our calculator. We go to second and vars. We do number 2 is normal CDF. That's a range. We're going to do 25. Lots of 9s, 18.5 and 5.3 as our standard deviation. And that gives us a probability of about 11%. So this probability is about 11%. So if you think about this, it's not that, would not be that surprising if I randomly picked one team and they watch more than 25 minutes of YouTube. Okay. So now we're going to get into what we talked about today. This is a sampling distribution because we're taking a sample of size 10. We're taking an N of 10. So now what we're doing is we're taking 10 teens, asking how much they watch, averaging those 10. So what ends up happening is, because this is an SRS, because this is random, I can say the mean of all of those X bars I would take equals the real mean. So it equals 18.5 minutes. What that means is, if I took groups of 10 over and over and over again, and I built that. So again, if I was putting all these little X bars on the number line, and all of a sudden what would happen is, if I did enough of them, it would be centered at the real mean, 18.5. That's a rule. That's just something that happens. When we do something randomly, we have an unbiased estimator. So the next thing is our standard deviation. Our standard deviation is our independence check, that 10% condition. So what I'm going to do is I'm going to do 10 times N, and I'm going to compare it to big N. So I'm going to make sure that my sample is no more than 1/10 of my population. So I'm going to do 10 times 10 is 100. And I'm going to compare that to my population. In this case, my population is US teens. I think it's safe to assume there are more than 100 US teens. Therefore, I can use this formula. The standard deviation of that sampling distribution is equal to the true standard deviation over the square root of the sample size. And again, what I want you to know, right here on the formula sheet, there's your mean, and there's your standard deviation. So now, if I plug in the numbers, I take 5.3, I divide it by the square root of 10, I'm going to get 1.676. So what this says is that on average, I would expect the average of the 10 to be 18.5 minutes, but I'd have some variability, and I'd expect it to be off by about 1.67 minutes each time. So there'd be a little variability to it. But as you notice, a whole lot less variability than just 1. So now what's going to happen is when I crack it, bring it down here to the bottom and work out, and I draw that same curve, while it is still centered at 18.5, what's going to happen now is these numbers here along the line are going to change. This one is going to be 20.176 when I add 1. This guy is going to be 21.852, and the third one is going to be 23.528. So if you think about it, what we did before, where we had that mean of we're looking for 25 up here. 25 was within our 3 standard deviations. Now, when we look at it, 25 is way out here. So what that is saying is the following. What is the probability that that X bar, that average of the 10, exceeds 25? So now we're going to use that same normal CDF. Our lower bound is still 25. Our upper bound is still lots of 9s. Our mean is still 18.5, but our standard deviation gets smaller because our sample size got larger. So now what's going to happen is I'm going to use this in the calculator with normal CDF. So we're going to do on second bars, normal CDF. Still have the same lower, upper, and mean, but now I'm going to make a smaller standard deviation of 1.676. And that's 5 times 10 to the negative 5. So if really what it is this 1, 2, 3, 4, 5 is what it is. So in this case, this is essentially 0. This is essentially 0, because anytime that I don't find my first non-zero until the 5th digit or later, I'm basically talking about an incredibly unlikely event. So this would be stunning. This would be really surprising to me. I mean, 5 out of what? You got your 10s, 100s, 1000s, 10,000. So 5 out of 100,000. So 1 out of every 20,000 times you'd expect this. So really, really rare. And the reason that is because the first time I was only dealing with 1 teen. The last time I was dealing with 10 teens average. So that's what we're dealing with when we deal with this practice. So hopefully that helped a little bit.